Center for the Ethiopian Educational Information and Communication Technology presents Educational Satellite Television Programs.
Hello, teacher. Hello, students. Welcome to today's lesson on the application of vectors. In the last lesson, we learned how to resolve a vector and to express a vector in terms of unit vectors. You have also reviewed dot products and their applications. Today, we are going to learn some of the applications of vectors. We will apply vectors to solve problems of geometry, algebra, and mechanics. Are you ready? Let us begin. Students, we are already aware that vectors have many different applications. Any 2 points on a plane form a straight line. A straight line in the plane is completely determined if its slope and a point through which it passes are known. These lines have an established direction. Therefore, let us see how we can write equations of lines using vectors. Observe this triangle. We can use what we have learned to prove that the perpendiculars from the vertices of this triangle to the opposite sides intersect at a single point. Remember, students, lines that intersect at a point are called concurrent. Let us mark our triangle like this. We can see that BC is equal to the difference between OC and OB. Similarly, CA is equal to OA minus OC, and AB is equal to OB minus OA. Our hypothesis states that BC and AD are perpendicular, so their dot product is 0. Therefore, we can deduce that the dot product of AD and the difference between OC and OB is 0. The same is true for the other 2 sets of vertices. In the same way, we may conclude that the dot product of BE and CA is 0. Therefore, the same relationship exists between the second set of angles as we see here. By combining these two sets of relationships, we see that the dot product of OA and OC is equal to the dot product of OB and OC. The dot product of OC and the difference between OB and OA is equal to 0, which means the dot product of OC and AB equals 0 as well. This demonstrates that BA and CF are perpendicular. Thus, the perpendiculars from A, B, and C are concurrent. Now let us try an activity, students. Please select a partner to work with. I will provide a practical problem, and you may use what we have learned about vectors to solve it. Here is a triangle. Prove that its perpendicular bisectors are concurrent. Go ahead, students.
Students, let's get ready. Begin. Time's up! Let's get back to our lesson.
Welcome back, students. Let us go through the steps of solving this problem. Join O to the midpoint F of AB. BC is equal to the difference between W and V, and OD is equal to half of the sum of W and V. OD and BC are perpendicular, as are OE and CA. Therefore, we can form this conclusion. Thus, we can extrapolate that the difference between the squares of U and V is 0. Therefore, 1/2 times the dot product of the sum of U and V and the difference of U and V is 0. OF and BA must be perpendicular. I hope you were able to follow along, students. Please ask teacher any questions you might have after the lesson. Observe this collection of vectors. Note the relationships between the various points. Vector P1 minus vector P0 is equal to x1 minus 0 and y1 minus 0. They are position vectors corresponding to points P1 and P0. You can see the line L through P0 and P1 is parallel to this vector. If P is any point on L, the position vector is obtained by this relationship. The symbol lambda represents a scalar. If a direction vector V and a point P are given, the vector equation of the line they determine is expressed this way. The scalar is a real number, and V cannot equal 0. If V, P, and P0 are established with these coordinates, the equation can be written this way. Once again, the scalar is a real number, and A and B cannot be equal to 0. Students, this system of equations is called the parametric equation of the line L. P0, whose direction is that of the vector V, is called a parameter. If A and B are both different from 0, the standard equation of the line applies. These are the vector equations of a line, students. Do you think that you can determine a parametric line equation for yourselves? Pair up with the same partner as before. Please find the parametric equation of the line through 2 and 3, and with direction vector 4 and 1. You may begin.
Students, let's get ready. Begin. Time's up. Let's get back to our lesson.
Hello again, students. Let us see how you solved this problem. We can define P0 as 2, 3, and V as 4, 1. Therefore, the vector equation of the line is 2 plus 4 plus the product of the scalar times 4 and 1. This equals 2 plus 4 times the scalar and 3 plus the scalar. The parametric vector equation is x equals 2 plus 4 times the scalar, and y equals 3 plus the scalar. Were you able to make the correct calculations? Great work. That is all for today, students. We have learned some of the ways we can apply vectors. We have also learned about the vector equations of a line. Until next time, thank you, teacher. Thank you, students.